What is going on, everyone? Hey, this is Will Button, and this is DevOps for the Rest of Us, where I'm taking you each episode through applying DevOps principles, easy for me to say, DevOps principles to your existing projects. So this week, I'm going to keep it short. I know the last 2 weeks I have blown way over on my time, so we're not going to screw around. Last week we talked about Kubernetes, and you saw a little bit about how to set that up and get it running. So this week we're going to compare that with ECS, Amazon's ECS Fargate service. So let's just jump right into it here. To get started, now if you remember last week on Kubernetes, we had to, we launched the Kubernetes create thing that had us create an IAM profile that was used by our Kubernetes plane, our Kubernetes control plane to control the service, right? So in ECS, we're just going to click Create Cluster here, and we get 3 choices here. So we're going to use this first one, powered by AWS Fargate. The other option you have is similar to the Kubernetes setup we did last week, where you build your own EC2 instances to manage that, or you can do EC2 Windows for if you have a Microsoft Windows platform. But we're using Fargate, and we're going to click Next Step here, give it a cluster name. We'll add our tags. So name is going to be Incident Manager, ECS, the service, which is the service that it provides in my environment. The environment, so this is kind of misleading for the environment because I'll use the same cluster for dev, staging, and prod. The role we'll give it is Fargate, and then our final tag team, which is going to be DevOps, even though that's the same people as everyone else. So we've got this Container Insights option, which is kind of new. I don't know when they released it, but it's new to me. That just allows us to dig into the metrics about how the CPU, memory, disk, and network is performing on our cluster. So we're going to check that. Actually, I can just see that you've got that in the way. So let me get rid of that. There we go. So that was the checkbox I was talking about there. So we'll hit Create, and it's done. So quite a bit more simplified, if that's a phrase. It's a bit more simplified than what we saw with Kubernetes, and our cluster is probably up and running and ready for us to go. But that doesn't really, it doesn't mean our application's up and running, right? So there were 2 steps to it in Kubernetes last week. We built the control plane, then we built the worker nodes, and then we launched our application. We don't have any worker nodes here either, and we're not going to, because that's going to be managed by Fargate. That's what Fargate is doing for us in this scenario. So Fargate is going to dynamically build the EC2 instances under the hood for us whenever we're ready to go. So let's move on to that part. So in order to create an application or launch an application on this, we need to tell it which application we want to run, and that's going to typically come from a Docker container, right? So a Docker container is going to be living in our repository, our ECR repository, and so for that to work, we need to create a repository. So I'm going to go over here and I'm going to click Create Repository. And I'm going to give this the name of Incident Manager. So we've got this option for tag mutability here, which is pretty cool because it allows you to prevent pushing container images over something that's already in the repository with that name. So we're going to turn that on. And this is another new feature I hadn't seen until recently, Image Scan. It actually does a vulnerability scan on your Docker image whenever you create it. So we're going to turn both of those on and click Create Repository. And so now if I go into this repository, I'm going to actually click the button here, View Push Commands. And the push command is how, these push commands are how I'm going to push a Docker image up into this repository. Let me show you real quick here, because we have no Docker images in the repository, right? So I'm going to hit View Push Commands, and I'm just going to copy this over here and then paste this into my terminal. And that's going to log me in. So the Docker image itself that I'm building, I didn't get, in my own project, I didn't get it to the stage where it's ready to be built yet. So last night I went and found a Docker image that we're going to use. It's a bulletin board app. But if we take a look at this here, we've got a Docker file, and so that's what we're going to build. So I'm going to copy this command, and this command is docker build-t, tells it to tag it as incident manager, and then the dot tells it to look for the Docker file in this current folder. So that's built. The next thing we want to do is we want to tag this for the repo that we're going to send it to. So let's put that command in there. And it's a long command, but basically it's just saying docker tag, which we're going to tag it then with incident manager latest, and then it gives it the name of the repository that we're pushing it to, and that's the repository we just created. So it's tagged, but it's not pushed up there yet. Tag just put the tags on that local Docker image that we just built. So now we'll push that up there, and that's going to push. So while that's pushing up there, let's go back to ECS. And we're going to run through this. So we're going to go into Incident Manager. And we're going to click Create Service. So now the service is the running environment that we're going to deploy. If you remember last week, if you watched the Kubernetes episode I did, so whenever we did that, there was a Kubernetes manifest, and I deployed that just by copying and pasting a GitHub URL that pointed to the manifest file. So if you think about that, that was easy because that was just copy and pasting one command in there. And so that's because the manifest was already built. Here, we're actually going to build the manifest ourselves, right? So I'm going to tell it the launch type is Fargate, and I don't have a task definition for it. So let's go create a task definition. So we'll go into task definitions, create a new task definition, tell it that it's for Fargate. And I'm going to call this bulletin board because that is the Docker image that we're going to be running. And then task role. So now this task role is going to be the IAM permissions that your running task gets, right? So this one doesn't actually need anything because it accesses nothing else. So I'm going to give it the default ECS task execution role here. And later in a couple of weeks, whenever I launch my product, you'll see that we'll build a custom task role for that, because what's going to happen there is the Docker images that I deploy for my application are going to have to access different resources inside my AWS account, like Elastic Cache and a database resource and different things like that. And so we're going to use IAM to control those permissions. Oh, and actually I lied about that. I just got those two backwards. The task role is the permissions used by the ECS service to launch our task. All right. So that means it needs permissions to download an image from the Docker registry, for instance. And so it's going to have those. Our task execution role is the one that I was just explaining. That's the permissions applied to the running container once it's launched. Task memory, this is just a little simple application, so we're just going to give it just a little bit of resources. One thing to know here, this task memory and task CPU, it's for the task, right? So if you have multiple Docker containers running inside the task, then this memory and CPU is going to be shared across all of those. And so now we're actually going to add the container. Our container is going to be called bulletin board. And then we need the URL, or the image URL. So let's grab that from the ECR. All right, so here is the incident manager repository we created. Our upload is complete. You can see that here in the console, and here is the URI for that. While we're here real quick, let me show you real quick, because we turned on the vulnerability scanning, and so if I click on there, you can see that we've got 6 high vulnerabilities, 6 medium, and 17 low, and 36 informational vulnerabilities in that image I just pushed up. And then as you scroll down through here, you can see each of the vulnerabilities that it found, and then it gives you a link to the CVE where you can find more information on that. So that was pretty cool. I like that. Meanwhile, though, our Docker image is going to be this guy that we copied and pasted. Another little tip for you, I've got latest set here. Once you're running your own Docker images, I strongly encourage you not to use latest, and have some kind of a tagging system for your Docker images that allows you to tie that to a specific commit or release in your code repository. And the reason for that is because what's in latest? Well, you don't really know. It's whatever the latest thing was pushed up there, right? So it could be, new features that have been pushed to your repository, or, downloading updated libraries that you haven't tested against, or there's all kinds of things that could go wrong there. And it's okay for those to go wrong as long as you know that it's happening. The reason I don't like latest is because if a Docker service restarts in the middle of the night and you're using latest, it may get those updates, which breaks it. And what would have been a seamless restart in the middle of the night is now an outage that's rolling you out of bed. So you can set soft and hard memory limits on the container that will cause the container to have a certain amount reserved, or kill the container when it exceeds a certain amount of memory. And our container port, so this is what port our Docker container is listening on. All right, I know that this one is on port 8080. I can actually show you that real quick. So if I take a look at the Docker file, you can see right here we have exposed port 8080. And then we've got this, these are all advanced features that I'm not going to use for this because we're going to have our load balancer taking care of this. Basically, it allows you to run certain commands to verify that your Docker container is healthy. We're actually going to have a health check endpoint that the load balancer will use that will determine that. And then there's a bunch of other advanced details, start timeout, stop timeout, that allow you time for your container to come up and be ready to start servicing requests. Same thing for idle down. You can disable networking. You can set specific links and host names. We're not going to spend too much time on that because I just want to focus on Fargate right at the moment. And we're going to add this in there. So now we've got our container added to our task definition. You can see we could add additional containers there as well. And we hit create and we're good. So now we can come back over to here. And I'm going to have to refresh the page to get it to see that task definition. So we're doing Fargate service with bulletin board. You can, so now your task definitions are immutable, meaning once you create it, you can never change it. You just add new revisions on top of it. And then it always shows you what the latest revision here is, which makes it pretty nice whenever you need to roll back. You build a new task definition, you can roll back using the latest tag. Here's where we'll specify which ECS cluster we want to run it on, and then we'll give it a service name. And the number of tasks, I just want one, but you can have as many as you need there. And then minimum and maximum percentages here is used for whenever you're making updates to your task that launches new task definitions or new copies of the task definition. It uses this to prevent either underloading or overloading your service. And then you can do rolling updates or blue-green deployments. And so I just saw yesterday, I think, where CloudFormation now supports the code deploy blue-green deployments. So we're going to actually be implementing that in our service whenever we deploy that. All right, next step, service discovery. We're not going to use service discovery, but service discovery is I don't think I've talked about that in any of these live streams or not, but it's kind of like an internal DNS, for lack of a better term, so that if your applications look for something by the name of DB or a database, that name internally resolves to where your database servers are. It's kind of cool. It's a little overkill for this bulletin board app, but we'll see that in action before too long. All right, so we got to configure our VPC. So we are going to use that VPC. And here's where we get into our subnets. So now the subnets, if you watched, what was that, the first or second live stream I did, we built the VPC and we built it with public and private subnets. So the public subnets are the ones that have public IPs and they are accessible from the internet. Private subnets are the ones that are only available inside of our VPC. So my ECS service here, I only want running on the private subnet, right? I don't want it publicly exposed, which may seem a little confusing at first because you think, hey, if you launch it in your private subnet, how is anyone going to access your bulletin board? And the answer to that is through the load balancer. So our load balancer will actually be publicly exposed and it will route traffic through to our Fargate service on the private subnet. For our security group, let's see, I think I created looking for a different security group here. I thought I created one that was just internal. Doesn't look like I did, so let's do that real quick. Let's call that internal access. Basically what this is going to do is it's going to allow any traffic inside our VPC to talk to anything else in the VPC. Because if it's inside the VPC on this small of a network, it's fine for it to talk to anything else. Now, if you had a much, much larger network, you know, with different restrictions, you know, like financial requirements that you had to meet or medical compliance requirements, you would want to lock down specific traffic to different sources. But we're not in that environment here. We are, however, though, in a VPC, so I need to look up and see what the CIDR range for that is. All right, so we're launching in this VPC, and our CIDR range is 10.192.0.0/16. So that is the range that we will allow in here. Autoassign Public IP, we're going to disable that. And here's the part that really frustrates me about the ECS service is I tell it I want to launch it on an application load balancer, right? But I don't have any application load balancers built, so we've got to go build one. So let's do that, and that is done over in the EC2 console. So as soon as that loads, we'll go over here to load balancers. We'll create one, and so you get a couple of options here: application load balancer, network load balancer, or classic load balancer. Almost all the time you're going to be working with an application load balancer because you'll be dealing with HTTP and HTTPS. If you need to route based on TCP or UDP, then you can use a network load balancer. And I can't think of any, off the top of my head, I can't think of anything that the classic load balancer provided that isn't covered by one of these two options. So we're going to pick an application load balancer. The name is going to be Bulletin Board LB. It's going to be internet facing IPv4. And we're going to open up port 80 and put it in this VPC. And remember, so this is our load balancer, so this is going to be publicly exposed, so we're going to assign it to the public subnets. And it's telling us we're not using any secure listener, HTTPS. That's right, we're not for right now. Depending on how long this live stream goes, we might come back and add that. So we need to create so we need to create a new security group, and we're going to open HTTP, and that gets open to the world so that anyone in the world can access it. And then just in case we get to it, I'm going to add HTTPS as well. All right, so target groups is where our application or where our Fargate service is going to register our load balancers. And so this is why I don't like this setup, because we can't proceed on building our load balancer or building our ECS service because the load balancer doesn't exist, and we can't completely build our load balancer because it's asking about target groups. So what you have to do here is just create a target group name. I can't even blow past that. I don't know why I keep putting a G in there. And then when it comes to registered targets, we're just not going to register anything. So that's here. Make sure that, so it'll take it a couple minutes because it's provisioning. We need to give this would like to give it that internal security group that we just created, but I don't see it listed here. I know we built that, didn't we? Yeah, it's right there. Did I build it in the wrong VPC? Let's see. I did. That's in the wrong VPC. All right. Let's name this correctly. And we want to allow all traffic on 10.192.0.0/16. All right, let's see if this is going to work. So now our new load balancer shows up here. The container to load balance is our bulletin board container on port 8080. Our production listener port. All right, so now this is where, this is port 80 that we exposed on the load balancer, and that's going to go through and load balance on our target group, and we want this to just load balance on everything. And I think that's going to be our health check path. Evaluation order is 1. All right, let's do this real quick because I want to make sure that that's clear. Let's jump over here. All right, is that working? There we go. Okay, so I want to explain what we did there real quick. So we have our Fargate service, right? So let's say we have Fargate right here. And then inside of that, we've got a Docker container that we're launching that's going to be our bulletin board. I'm just going to call that BB. And this is all inside of our VPC, right? So it's internal, no public access to that. And then we created this load balancer. And so we're going to we'll just put LB over here. And we want this bulletin board application that we're launching to be available on the internet. So someone out here in their browser is going to type in the URL for that, and that's going to come in on HTTP port 80, right? But our Docker container here is listening on port 8080. And that's what the load balancer is going to do for us. The load balancer is going to receive this traffic on port 80. It's going to evaluate the rules, which we only have the one rule there. And it's going to say, oh, hey, this traffic needs to go to this dude on port 8080. And so it's going to do that port translation for us. And same thing, if we get the time here to set up SSL using HTTPS, that comes in on port 443. Same thing, the client's browser comes in, hits the load balancer. That's going to validate the SSL certificate, right? That SSL certificate gets validated right here out on the load balancer. Once it's validated, the same traffic rules apply, and it sends the traffic from port 443 over to port 80, right? So that's kind of the setup that we've got going on over here. All right, we'll switch back over to our laptop here. And now we're just going to click our way next all the way through here until our service creates. All right, so that's it. That's ECS Fargate, which is cool because that took 30 minutes to set up. Now, you can see the status here is provisioning. It's since this is the first time we've ever run anything on this Fargate cluster, it's got to provision the resources at AWS, and then it's got to download our Docker image and get that up and running. But ideally here, within just a minute or two, oh, there it is. It's going to be up and running. So let's actually do this. Let's see if it's going to work. Go back over here to EC2. Take a look at our load balancer. So if we look at the listeners on our load balancer, here's port 80, which just means the port that it's listening on. It forwards to bulletin board. So if we take a look at bulletin board, that's a target group. Now, if I did everything right, we're going to see our running Docker container listed there. Oh, denied. Denied. What do we got listed here? So it did create a new target group. All right, so let's go fix that because I want to see this work. But we do have, notice that we do have our container running on port 8080 reporting as healthy. Let's go back here to our load balancers. And let's change that. So we'll hit the pencil to edit this. And we're going to change this from bulletin board to the one that it created for us. I have no idea why it's kicking us out to another screen to do that. It's actually not what I wanted it to do at all. Oh, I've got to hit this pencil. So you got to hit this pencil and then this pencil and then this pencil. And now we can choose where we want it to go. Let's hit update. Default rule was successfully updated. All right, let's see if it is updated. We've got this DNS name here. So I'm just going to copy that, open a new tab, paste it in. And there's our working service. Not too bad, right? Things you could do from here. Nobody wants this URL. It looks like shit. So you could, if you have a domain set up in Route 53, you can create a record in a CNAME record in Route 53 for the domain that you have, and that CNAME record would point to this load balancer here. And then you would be able to use your own domain name to get to that. But we'll save that for another time because we're at 34 minutes. And let's see if I can switch back over to the camera here, and that's where we are. So let's recap and configure or talk about Kubernetes, EKS Kubernetes service, and ECS Fargate real quick. So there was a lot of setup whenever we built Kubernetes last week. We had to create the IAM roles and then create the control plane and then create the worker nodes. Now EKS, we didn't do this last week. EKS, you can use Fargate as the worker nodes, just like we did here. We just didn't go that route. Yeah, so we had those steps. And then on ECS Fargate, you saw that we clicked Create Cluster. And from there, everything else was just about getting our application up and running. So the downsides to this is we did a lot of pointy clicky stuff today, right? Everything I did was in the console, and anyone else on my team can come through and change any part of that. And when they change it, how do we know? Kind of don't. So that's not an ideal setup, right? But I wanted to show you that so that you can understand, what's getting built piece by piece. Because now with what I showed you today, in our next live stream, we're going to actually take this apart in 3 steps. So first step is building by pointy clicky stuff. Second step, we're going to build a CloudFormation template that builds all of that for us, right? So it's going to build a load balancer, it's going to build the DNS name, it's going to build the ECS task definition, all of that through a CloudFormation template. And then we'll launch that from my workstation here, and that's going to be how we do our first release of this. And then the third stage of that is where we take that CloudFormation template and that build process that we're running locally here, and we move that off to a deployment system, whether you're using AWS Code Deploy or Jenkins or Travis or whatever you've got, because in the long run, you don't want to be doing deployments from your workstation, right? Because the reason why is because if it happens from your workstation, maybe not everyone on your team knows about it, right? For instance, you could have someone that does a deployment, closes their laptop, and then goes home and doesn't really communicate that well. Well, if that deployment goes bad, it can go bad for a really long time before everyone else on the team figures out that a deployment happened. The reason that we're not jumping straight to that stage, though, kind of ties into our disaster recovery plans, right? So if we only have our deployment system able to deploy, then what happens whenever GitHub is down and we're dependent on those webhooks to trigger a deploy? So we're kind of building our backup method for deployments first. It also allows us to troubleshoot our deployment strategy to make sure it's doing what we think it does, and then we'll roll that out to our continuous integration, continuous deployment system. So that's what's going to be coming up next week. Possibly the week after that, because next week I might be able to get Stephen Kinsley from No Drama DevOps on here, and he'll share some of his experience with you of getting started in DevOps. But we'll find out. I'll let you know